Hey everyone, you know that feeling when you're faced with a multiplication problem that just feels a little too tricky to do in your head? Well, today we're diving into an ancient system called Vedic mathematics to pull out a technique that's like a mental superpower. It might just change the way you look at numbers for good. All right, let's just jump right in with a challenge. How fast can you actually solve 48 times 46 right now in your head? If you're going the traditional route, you're probably picturing columns and carrying numbers. It's clunky, it's slow, and honestly, it's not very fun. But what if I told you there's a ridiculously faster way? I'm going to solve it right now using the Vedic method. Don't even worry about the how just yet. Just watch how fast we get to the answer. Think of it as a little math magic for now. Okay, you ready? Here we go. First, since both numbers are in the 40s, let's just anchor ourselves to a nice, convenient number, 40. That's our new starting point. So, from that base of 40, how far away are our numbers? Well, 48 is just 8 more, and 46 is 6 more. These little differences, plus 8 and plus 6, are all we're going to need. Now, the answer comes in two simple parts. To get the left half, we do a cool little cross add. Take one number, let's say 48, and add the other number's deviation, which is 6. That gives us 54. Then we just multiply that by the first digit of our base, which is 4. So 4 times 54 is 216. The right part is even easier. Seriously, we just multiply our two deviations. 8 times 6 is 48. So now we have our two pieces of the puzzle, 216 on the left and 48 on the right. And now we just put them together. We take our 216 and our 48, do a quick little carryover, and boom, 2028. Just like that. No messy calculations. Pretty cool, right? So you want to know the secret behind the trick? Let's break it down. The secret isn't some kind of wizardry. It's a really smart and logical idea from Vedic maths called working bases. The whole concept is just why always start your calculations from 10 or 100? Why not pick a base that's actually close and convenient to the numbers you're working with? Now, if you want the official name, it's the Anurupyena sutra, which simply means proportionately. And that word is the entire key. We chose 40 because it was easy, did our simple math, and then we just had to make a proportional adjustment to get the final correct answer. And that's where something called the ratio comes in. So, what is this ratio? Think of it as our correction factor. In our normal everyday math, the ratio is just 1. But when we decide to use a working base like 40, we have to account for that change. Since 40 is 4 times our main base of 10, our ratio is 4. If we used 60, the ratio would be 6. This simple number is what lets us adjust our answer and make the whole thing work. Okay, now that you've got the big idea, let's walk through the exact blueprint. It's just 5 steps, and they're the same every single time. All right, here's the full playbook. First, pick that easy working base and figure out its ratio. Second, find the deviations from that base. Third, this is the heart of it. Get the left side of your answer. You multiply the ratio by that cross sum, one number plus the other number's deviation. Fourth, get the right side, which is just the product of the two deviations. And finally, step 5, you combine them. That's it. You know, the best way to really learn something is to just do it. So let's run through some practice problems together. You can just follow along in your head, no paper needed. We'll stick with numbers near 40 for now. Okay, let's try 42 times 48. Our working base is 40, so our ratio is 4. The deviations are plus 2 and plus 8. For the left side, we take our ratio, 4, and multiply it by the cross sum of 42 plus 8. So that's 4 times 50, which is 200. For the right side, it's just 2 times 8, which is 16. Now, how do we combine 216? This part's important. Because our main base is 10, which has 1 0, the right-hand side can only have one digit. So with 16, we keep the 6 and carry the 1 over to the left. 200 plus that carried 1 is 201. We put that next to our 6, and there's the answer, 2016. Okay, that was pretty slick. But what happens if one of our numbers is actually below the working base? This is where the method really shows how powerful it is. Let's tackle 38 times 43. Base is still 40, ratio is 4. But the deviations are now minus 2 and plus 3. The left side is our ratio, 4 times the cross sum of 38 plus 3. That's 4 times 41, which is 164. Now the right side, minus 2 times 3 gives us negative 6. So how do we handle 164 on the left and a negative 6 on the right? It's actually really simple. that 164 on the left really stands for 164 tens, or 1640. From that, we just subtract the 6. 1640 minus 6 gives us our final answer, 1634. It's just a simple subtraction. And the best part is, this scales up beautifully. What if you're multiplying numbers near 200? Well, we just use 200 as our working base. Now, for 3-digit numbers, our main base is 100. So to find our ratio, we just divide the working base, 200, by the main base, 100, which gives us a nice, simple ratio of 2. The rest of the logic is exactly the same. Let's try 203 times 205. Working base is 200, ratio is 2. The deviations are a super simple +3 and +5. For the left side, it's our ratio, 2, times the cross sum of 203 plus 5. That's 2 times 208, giving us 416. For the right side, it's 3 times 5, which is 15. Now remember our rule. The main base is 100, it has 2 zeros. That means our right side needs 2 digits. Well, 15 is perfect. No carrying needed. We just merge them together. 41615. Okay, one last one to really lock it in. 196 times 192. Deviations from our base of 200 are -4 and -8. The left side is our ratio, 2, times the cross sum of 196 minus 8, which gives us 376. The right side is -4 times -8, which is a positive 32. We need 2 digits. 32 has 2 digits. Perfect. We just stick them together, and you get 376,322. See how consistent it is? You now have the complete method. To really master this and turn it into a lightning-fast mental tool, there are just a couple of key points and common traps you need to keep in your back pocket. So, let's recap the golden rules. First, always pick the most convenient base. Second, get that ratio right. It's just your working base divided by your main base, either 10 or 100. Third, remember the process never changes. Ratio times the cross sum on the left, product of deviations on the right. And finally, always make sure the number of digits on the right matches the number of zeros in your main base. There are really only 2 major traps people fall into. The first, and by far the biggest, is they forget to multiply the left side by the ratio. That ratio is the whole secret sauce. It's the proportional adjustment that makes everything work. The second thing is just remembering how to handle a negative on the right-hand side. Just treat the left side as tens or hundreds and subtract. If you can avoid those 2 things, you've got this down. You know, this technique really brings this quote to life. It takes a problem that seems complicated on the surface, and by just changing our approach, makes it elegantly simple. It's a perfect example of what makes math so beautiful. And really, that's the bigger idea to take away here. We didn't change the problem itself. We just changed our starting point, our perspective. And that simple shift made something difficult feel easy. So the question I want to leave you with is this. What other problems in your life could suddenly become simpler if you just tried changing your starting point? Thanks for watching.